So good morning, everyone. Nader, I'm the CEO of Exyn Technologies, a spin-out from Penn. We were formed in late 2014. Had the privilege of leading a great team over there to essentially create Exyn. And what is Exyn? So Exyn, in a nutshell, what Google is doing to the car to make it fully autonomous, essentially we are doing to the world of drones to make the drones fully autonomous, so without the pilot in the loop. We've seen a lot of coverage and press attention on drones in general, and so we go to great lengths to discern ourselves and differentiate ourselves from drones in that we're not about the vehicle. Much like Google isn't about the vehicle, we are not about the actual drone itself. We are in the world of aerial robotics. We focus on the AI software that goes onto the drone to make them intelligent. We focus mostly on commercial missions, commercial applications right now, and we focus on the safety aspects to make sure that the drone can execute the missions safely, reliably, robustly, in complex environments, because these are real-world environments. And what that basically means is if you're going into a commercial environment, these are not only complex, but you've got to be able to guarantee the safety of the flight. And in doing that, if we can guarantee safe flight, then therein lies the value. We will be able to extract a lot of value by automating a lot of operational processes and transforming the way things are done in large organizations. The way we look at it right now, we've seen drones being deployed, and I mean drones being deployed in very, very large industries. We look at oil and gas, wind turbine, inspection, energy in general, telecoms, assets out in the field, and construction. These are multi-billion, if not trillion-dollar industries globally. And they've been successfully deployed. They're already adding a lot of value. And this is a typical scene from a drone deployment. What you're seeing is a drone being used to inspect a flare stack, and therein lies the actual problem description itself as well. So even though this is a good replacement for a guy wearing a harness and dropping rope and climbing the flare stack, you simply deploy a drone and you get camera on the actual flare stack, and you can do the inspection, identify areas of corrosion or rust, cracks. Therein, however, is also the challenge in that what you're seeing over there is you can typically only operate in blue skies, no obstructions in the area, and also right now what you're seeing is 3 people, 1 drone. So it's not very scalable either. So what you're seeing over here is there is a pilot. So if I can use this. So there's the pilot who is focused purely on flying the actual drone itself. You've got the spotter who's telling the pilot what to do, and this over here is the subject matter expert. This is the person who's actually looking at the feed and saying, okay, I can spot cracks and corrosion. So the effectiveness already being proven, the market is already primed because the drones are being deployed, but there's still a significant opportunity for improvement. So the proposition we are bringing to market is the fact that we can remove the human operator, we can improve the performance of the actual drone itself by automating it, making it into an aerial robot. And if we can have one aerial robot, what would it look like to have multiple robots collaborating and cooperating on the same problem? So now you can talk about scalability and looking at larger problems without having pilots in the loop. And the other thing is also, given the nature of the technology, which I'll describe briefly, whereas right now we can really only focus on outdoor applications, our technology allows us to go indoors. So we can actually deploy the robots in GPS-denied areas without having, again, operator input. So what does that mean in terms of business benefits? We can significantly lower the cost of the actual operation itself. Given the fact that we're automating it, we can gather a lot more data, higher quality data. Given the fact that we're removing the human element, we can increase the frequency of operations, and in certain situations, you will be able to lower the risk or eliminate the risk in certain operations. For example, in mining, if you're going into a deep mine and doing inspections in dangerous areas of the mine, right now the option is to close off the mine. You have to do that. But now if you can automate it and send in robots, the risk can be mitigated, and now you can open up the mine and build a plan to effectively reopen that part. How big is the market? If you look at various industry reports, there will be, obviously the consumer segment, which gets a lot of the attention right now, but that happens to be one of the smaller segments in $3 to $4 billion, just in terms of hardware sales. Another segment is obviously defense. That's significantly large. However, we focus on the commercial space. And when you look at just the commercial space, you're looking at anywhere between $20 billion in terms of the hardware sales. But if you look at it more holistically in terms of the actual services and the software that's being put in there, PwC estimates that at $127 billion annually. When you look at the breakdown of that market, what we've done and what we focus on is the inspection, surveying, and mapping, what we call asset visualization. So what you're asking the robot to do is gather data. You're not carrying things, you're not trying to do anything terribly intensive in terms of carrying a payload. You're carrying a camera, you're carrying a sensor, you're gathering data, and you're building maps. That in itself represents nearly half the $127 billion opportunity. It's a significant part of that. So what does the proposition look like? This is our latest iteration of the actual hardware. And what you're seeing over here, I have to stress, is entirely off-the-shelf components. There is nothing proprietary in terms of what you actually see physically in this robot. What we do is the software that goes onto that, and that is really where the magic is. And that is the hard problem. If you imagine what Google is doing to the car, they're not manufacturers of automobiles. They effectively take off-the-shelf sensors. They have developed their software to go onto it so it can drive fully driverless. So that is effectively what we are doing. So we integrate it with the off-the-shelf hardware. And what we do on top of that is we add third-party application software to make it more specific to the actual industry problem we're trying to solve. For example, if we're going into a warehouse, we are not about barcode scanning. Thankfully, there are a lot of companies that do barcode scanning. We're not about warehouse management systems either. Thankfully, there are a lot of those companies as well. So we partner with existing solution providers so that we can enable their data capture and feed the high-quality, high-frequency data into their systems to drive better business decisions. Again, given the fact that the hardest problem to solve is the automation of things, that's where we can actually drive the highly differentiated capabilities. So what does that look like? We actually ran a video which demonstrated the technology capabilities, and we were thankfully picked up by TechCrunch in a feature article that they did. And I'm going to play the video for you. And the key thing to realize over here as I play it is that what you're about to see, the robot itself has no prior map. What it's doing in effect is building the map as it goes, and all it's been told is to go from a point where it is to a relative point in some part of the office. And there are various obstacles in the way. And what you'll see is the guy on the bottom left over here is giving the instruction to take off and go to where the yellow point is. And if you imagine that yellow point can be on a map, in a warehouse, in a mine. You can predefine that. But the key point over here is that the robot itself has to negotiate and discover the frontiers of the environment it's in and constantly build a path that's optimal for it to get from point A to point B. And I'll stress that this is happening real time on board the aircraft with absolutely no external infrastructure or support. So all the sensor payload, all the computational capabilities are all on board. And what you'll notice in the bottom left over here is as it's actually going through the environment, it's discovering more about the environment and constantly planning and replanning its path as it goes. And given the time constraints, I've been warned I've got a little time, so effectively it's going through this. And you'll notice the interesting thing about this and comparing it to what Google does, we have to operate in three-dimensional space. And we don't have the benefit of Google Maps. So all of this is on board. This is the real hard problem. And one of the reasons why we can do this is because we're leveraging 10 years of research at Penn for it to be able to jumpstart our developments. And it lands safely. So to jump to how that can be applied, that's an interesting technology. How can it be applied? I've mentioned construction. Anyone who's had a home improvement project, brought in contractors, you'll know the pain of things going over budget, taking twice as long to complete, and ultimately you're never satisfied with the end result because it's never really to spec. That is pervasive in the construction world. At the bottom over there, there's a McKinsey study that estimates the global construction industry being a $8 trillion industry annually, and $3 trillion of that is waste and inefficiency. So that is the construction industry's pain point. Not to say that we're going to be a $3 trillion company, but we can help the construction industry in reducing that pain. How we do that? Effectively, if the construction managers can have better quality information, high quality information, those inefficiencies and waste can be lowered. And that is what we will be enabling. In terms of our path to market, right now we're working directly with our first customer, which is in the construction space. We're working directly with end users to have access to the problem. But over time, we want to work with the solutions and integrators to enable their solutions, and ultimately, we want to enable manufacturers. The way we work right now, even though we're a software company, we provide the full stack of hardware and software. So we sell the hardware, that's one-off, but the really interesting part is the software licensing, where we license per unit per annum. So that's a long annual recurring fee model. So where we're at right now, we're in the first stage. We're proving the technology. We're working with pilot customers. The next step is to scale in terms of working with other customers, bringing on other industries so we can prove the technology further and move from prototype to product. And ultimately, the third step is to scale, where we start licensing the software and we abstract ourselves from the actual hardware. That's where the real scale begins. In terms of our team, we've got a stellar team. Dr. Vijay Kumar, the Dean of Engineering, is actually the co-founder of the company. We're leveraging his research from the GRASP Labs. We've been very fortunate to bring on board Jason Duranick as our chief engineer. He comes over from Sikorsky Aircraft. So when a Black Hawk helicopter automatically selects a landing site and automatically lands without hand on stick, that's actually his work. We were also very fortunate to have Paolo Perjanian, the ex-CTO of iRobot, on our board. He has startup experience and very, very hands-on in terms of kind of helping the company grow. And myself, I've worked in startups as well as large companies, but always in starting up new lines of business and new revenues. So we've raised $7.3 million in 2 rounds plus some convertible notes to date. Our commercial traction, we've signed on our first pilot customer, and we've got qualified interest from warehousing, mining, and I'm delighted to say we've got our first investor from the government space who's going to be introducing us to certain work programs in the government space. So those are going to be the next kinds of projects that we're going to be developing. And our plan is to drive commercial development and develop our prototypes for our first pilot customers. But in doing that, we have to expand our technical team, build out our lab, and get ourselves ready for our next round, which is where we will start moving the prototype to product.
Thank you.
Thank you.